Hi, good morning or good afternoon. This is Dan Enthoven from Domino Data Lab. Thank you for joining our presentation today. I want to introduce the talk by saying this. Domino for several years now has been working with many leading data science organizations around the world. And one of the great pleasures of being able to do that is the things that we learn from working with them about mistakes that get made or ways that they improve their processes and what they view as best practices. What this presentation is about is really that, which is what are the things that we've learned from working with our customers that we think are important for data science teams to think about as they grow and scale their data science operations. I'm going to start with a little bit of housekeeping. People often ask, can I get the slides? Definitely. Would love to share them. You can email me, dan@dominodatalab.com, and I'll send you a copy. We also have a white paper based on this presentation, and I'd be happy to share that with you as well. Next question, can I ask questions? Absolutely. There is a chat function with GoToWebinar, and please feel free to type questions in there. At the end of the webinar, if there is time, I will be happy to answer those, or we can follow up later as well. And then finally, if you want to learn more about Domino, please email me. I'd be happy to talk more about what we're doing, or just come to our website, dominodatalab.com. Most of the presentation, I'm not going to talk much about the product. So I do, for people that don't know what Domino is, just very quickly give an overview of Domino. So we're a data science platform, and what that means is we provide a workbench for data scientists to do their work, its tools, its compute orchestration, its centralized knowledge and collaboration, and it's a full lifecycle platform, meaning that we go from ideation and kicking off projects and starting with that all the way through to deploying and monitoring production models in a variety of ways, APIs, dashboards, batch jobs, etc. When people say, well, how is Domino different from whatever else is out there? The things that we really focus on are openness and flexibility. So we allow people to use different tools, Python, R, Julia, different IDEs like Jupyter or RStudio, etc. We have a huge focus on reproducibility, and our reproducibility engine is important for companies in regulated industries to be able to track and log their work, but it's also really important for collaboration and sharing of ideas and creating that central hub for knowledge. I'll also mention that we have really top-rated customer success and customer experiences. For people who are interested in learning more about this space, I'd encourage them to get the Gartner Magic Quadrant for Data Science Platforms, and they can learn more about Domino and what we're doing there. Who we work with? So we work with companies across many different verticals and all around the world. We work with large organizations, many of the companies here I'm sure you've heard of. We work with startups. We work with companies that are doing all kinds of data science and analytics. What they have in common is that these are organizations that are committed to having data science as a core corporate capability. So it's not something that's on the side. It's not something they're dabbling in. These are companies that are saying, hey, how do we use data science to get really great? And the reason they want to do that, of course, is because there's so much promise in data science these days. Just a few examples, Allstate, in their claims processing alone, one project saved them $40 million a year. At Amazon, amazingly, 35% of their sales come from product recommendations. So that's predictive analytics, figuring out what products to show along with the one people are looking at, and it's driving huge revenue gains for them. New York State, fraudulent tax return detection, $450 million. These are real wins. And even more than the wins, of course, is the hype, right? So if you look at the earnings calls of publicly traded companies, amazingly, how often do they talk about artificial intelligence? Well, it's through the roof. It came from nowhere to being on all these calls. And what's happening is, the CEOs of these organizations are trying to get people excited about the stock and the future of the company. And they're all recognizing that artificial intelligence, predictive analytics, data science, all of these things are a way that's going to make organizations better. In fact, I'll share a few different quotes on that. I like this one from Jeff Bezos. Machine learning will empower and improve every business, every government organization, every philanthropy. There's no institution in the world that cannot be improved with machine learning. I mean, that's sort of amazing to think about in terms of what people are looking at machine learning to do in terms of augmenting human capabilities for decision-making and functions. Another quote that I love is from Google. Artificial intelligence is more profound than electricity or fire. right? The expectations for artificial intelligence and data science could not be higher. But there's a third quote that I think is equally important to think about, and that's this one. With great power comes great responsibility. For those that don't know, that's what Uncle Ben says to Spider-Man. And think about stories you hear on the other side of predictive analytics. So Knight Capital is a great kind of case study in using algorithms for good and then having it all go haywire. They were an algorithmic trading firm. They were buying and selling stocks very, very, very high frequency and trying to sort of front run the trades and make a penny a trade or whatever. But fractions of pennies times millions times a day adds up. At one point, they were responsible for 17% of all trades on the New York Stock Exchange. It was an algorithm. They updated their algorithm. They botched the upgrade, and they left a training script in the box that was actually running this in production. And as a result, the organization lost $460 million in 45 minutes. You can look that up on Wikipedia. It's an amazing story. But essentially, it was a predictive algorithm that took away everyone's jobs over the course of lunchtime. It's really crazy to think about. And if you're an organization that says, hey, we're thinking of using data science for pricing, you want to think about, hey, how are we going to monitor and manage that? And there's many other stories of organizations. There's another one that I think about a lot, which was a credit card company that was using scoring to approve or not approve credit card applications online. They didn't realize that the data feed they were using had changed. And the change was pretty simple. In terms of giving a credit score, it was a number from 0 to 800. The organization providing the data decided to also include error codes in the score. And they put, for no credit score found, they put 999. And to them it was obvious, 999 means no credit score found. To the algorithm that was approving credit card applications, 999 meant this person has phenomenal credit. And the organization started approving all these applications. So you can imagine what happens next, right? Marketing thinks, wow, our campaigns are really doing great. We are getting tons of new applicants and they're all really top quality. Credit cards are flying off the shelves and out the door, and tens of millions of dollars later in losses, they sort of unwound that whole situation. So if you're thinking about data science, you should be thinking about all the possibility and the potential and the promise, but you need to also be thinking about what are the risks and what are the downsides and how do we control that? All right, so what are we going to talk about today? So start with just goals. How do you set goals for a data science team? And then what are the pitfalls that are going to keep you from reaching those goals? And we've seen a lot of them. What we'll do is we'll talk through some of the diagnoses, like what are the underlying causes that are making these things go wrong? And then what do we see companies doing about that? So what are the best practices that will help you achieve those goals and avoid those pitfalls? So start with the goal. Now, it's really hard with data science from our perspective because there's so many different programs that are out there. There's so many different objectives. There's so many things people are trying to do. And so it's hard to say, well, you should try to have AUC be, X. But there's three things you want to keep in mind. One is you want your goals to be measurable. You really need to have sort of quantitative ways of describing the quality and the outcomes you're delivering to the organization. And those are going to be things like ROI, dollars saved, or cost reduction, or accuracy of model. But make sure these are numbers and not sort of just vague goals like we want to do better understanding the customer. The next thing you want to think about is reliability in terms of hit rate. So it's great to be able to pick up a data science project and deliver a result to the business. We all know that many data science projects fail. In fact, you hear stories that 60–70% of them fail to deliver anything to the business. And so you want to ask yourself, well, of the projects that we kick off, how many are going to actually deliver value? And then finally, once you know that, then you can start talking about how scalable are we? How many projects can we do at a time? How many models can we run in production at once? How well can we sort of juggle all those balls or keep all those plates spinning? And so those are the three things that you'll want to be thinking about as you think about communicating the value of a data science program to the business. What are the pitfalls? What are the things that keep people from getting there? So as I said, many data science projects fail to deliver any value to the business. And there's a lot of different reasons why. So let's go through some of them. I often hear people say things like, well, I solved the problem, but, meaning they solved the problem, but it wasn't the problem. So the first thing you hear about is it was the wrong problem. And, I'll tell you just one story from my background here. I was at a company where the CEO was really focused on using all the data in the CRM and the phone system and email systems to do deal scoring to better understand sales. And so a lot of effort was put into that. And, we had this whole kind of pipeline health metric and this whole sort of complex analysis. And every time we brought it to the head of sales, he would sort of say, thanks, but no thanks. This isn't good enough, or this isn't really helpful. And we kept on thinking, well, if we make it better, if we make it more predictive, if we make it more accurate, it'll somehow turn the corner. But eventually the guy said, but look, the real thing is this. I know the quality deals in the pipeline. You coming in and telling me my business doesn't help me sell anymore. If you have a way to sell more and help me sell more, I'm all ears. But if you're just going to come in here and tell me the deals are bad, that I know they're bad, that's not good for anyone. And that was a really sort of brutal thing for the data science team. Amazingly, later I was talking to someone from another company, they had the exact same experience. They hadn't figured out the right problem to put their effort into. The next thing we see is, oops, problem was already solved by somebody else. So this is interesting. Domino, as I mentioned, is a collaboration platform. So when companies launch with Domino, they start putting all their different data science projects in. And one of the things we often find is multiple people working on virtually identical projects. One of our clients had 2 teams working on the same project. One was based in London, one was in Canada, and they had no idea that they had doubled the resources on this thing. And so it's really problematic because without a central repository, without a way of tracking work, people don't really know what's already been solved and what other people are working on. Another thing you hear is that people don't have the right tools to solve the problem. And so they say, well, I did the best I could with, my underpowered laptop, with my old tools, et cetera. This you hear from organizations that are having a hard time really supporting data science the way it needs to. And so what happens is people aren't given the compute power they need. They're not allowed to install the packages. They don't get permission to take new approaches. And so they sort of do what they think is a pretty good job, but they're not really invested in it, and it's not the best solution you can have. Related to that one, of course, is if it's too slow for the solution to matter. So many data science projects have a time constraint tied to them. You can imagine, one of our clients is Monsanto, and they use data science for predicting climate change and how climate impacts crops, and therefore what seeds to plant where and when. And if they were trying to update that model and they came up with the update, but it was past the planting season, it would have been useless. It's really important to understand, when is this thing due to get into production? Sometimes the problems get solved the wrong way. And this is a real interesting challenge where the data science team conceives of how the solution is to be delivered. They build it, they deliver it, and it is not delivered in a way that is consumable by the end users that are actually going to take advantage of it. And we've heard this. One example I have is from an insurance company where they built a new model for understanding risk, and they wanted the actuaries to use it, but it wasn't integrated with the existing workflow. And so it became a huge change management problem to get people to break their existing workflow that they've been trained on, that they were comfortable with, that they understood, and go to an entirely new system for part of their process. And they just couldn't get that system adopted the way they needed it to. And so it was sort of back to the drawing board to say, well, how do we get adoption of our fantastic new model, as opposed to just, did we build the model? Results being used the wrong way is a real risk. Google calls this the unintended consumer problem. And it happens when you build a model or deliver a model that then goes out into the wild and other people start using it for all kinds of ways. I mean, imagine if you do a customer segmentation model that is used to, understand customer churn or something. People may use that for things like, targeting advertising, and it might be right for that, but it might be wrong for that. And if you don't have control over the model and understand how it's being consumed, there's a real risk that you'll generate risk for the business, where people use it the wrong way, derive the wrong conclusion, and have a bad outcome. Sometimes the world changes while you're solving the problem. So that credit card company I mentioned, you could say the world changed on them because their data feed changed. Interestingly, I think a lot about climate change and insurance companies that are trying to price flood risk. And if you're using historical data and historical models, that may or may not be the model you want to be using if you're trying to understand flood risk. Take Houston, for example, they had 300-year floods in the last 2 years. So are you keeping up with what the world is doing today? And then finally, the dream problem would be that your problems multiply and you can't tackle them all at once. This is a situation that happens where the data science team comes in, they solve a problem, people love it. They solve a couple more problems, people love it. The backlog grows, expectations grow, they hire more people. This gets to the hit rate I was talking about before, where all of a sudden they're trying to solve 10 or 15 data science problems for different stakeholders in the organization. Meanwhile, production models that they already delivered need updating and need support, and they get spread too thin and they start failing. And then people start saying, oh, we had all these expectations for data science, but all these projects are late and underperforming, et cetera. So it's really important that as you think about scaling the organization, you think about what are the sort of cultural attributes, what are the processes, what's the technology, what are the things we need to put in place to make sure that as we scale, we can manage that growth. Okay, so diagnoses, what's going on underneath all this? Well, there's a lot of different things that lead to these outcomes, and I'll talk about a few of them. One thing to keep in mind is that data science really is different from software development. And I get into these discussions, especially where people who have a traditional software background and they read about, oh, it's really easy to do machine learning, and it feels like code and it looks like code, and they already know Python, so they think that data science is a lot like that. But it's really not. The sort of research and exploratory phase is very different for data science. Sometimes no answer is a valid answer. Sometimes the predictive power of your model just isn't enough to deliver a business outcome. You have to be comfortable with that as an outcome. It's really hard to test models. They're non-deterministic, and so this is a classic thing where you have a model in production and there's drift, and of course the New Relic monitoring says, hey, the model's working. Data comes in, data comes out. From a software perspective, the thing is fine, but from a business perspective, it could be highly problematic. And the other thing is just there's not really process metrics. There's not sort of story points the way you have in traditional software development. And so keep that in mind as you think about planning for a data science function, is that it's not sort of like, hey, we already have software engineers, let's just throw machine learning in the mix. The other thing that we see often is that as people start trying to solve problems, they actually focus on too narrow a part of the process, right? They don't think about all of the stakeholders in the data science process. So it starts with data scientists and they say, hey, what do we need to work better and faster? Well, we need like more powerful infrastructure. We need to get more compute power, basically. And we need to have flexibility to use the tools that we want. And that's important. That's an important thing to give to the data scientists. But remember that that's only part of it, right? So then you have to go to the data science managers. And data science managers have a different set of needs that they're trying to figure, right? So they want to accelerate project delivery. They want to start getting reuse. They want to start centralizing knowledge. They live in fear that the top data scientist who's been working on a project for 6 months or 9 months is going to get outbid at some competitor of theirs and leave the company. And so they want to make sure that they don't have key ram risk, and when they hire people, they can get those people effective very quickly. Meanwhile, the business leaders who are telling Wall Street on those earnings calls that, hey, we're doing AI and machine learning and whatnot, they want to know what the impact of this investment in data science is. And that's actually really important because data science programs can be expensive. And so if you're a data science leader and you're reporting up, you want to be able to tell those people, well, here's the ROI, here's what we are getting for the money. And the business leaders also want to know that's reliable, it's predictable, it's not introducing risk. They want to minimize stress to the rest of the organization, but they still want to see these things come through the cycle and get into production and deliver the value that they are expecting. And meanwhile, IT has a completely separate set of things that they're concerned about, right? I mean, they need to make sure that the infrastructure that they're putting in place is stable, it's long lasting, it is secure. They want to build on investments that they've already made, and they want to minimize the costs of supporting all of these different data science models or products or processes. I want to go back to the idea of tools, because oftentimes there's a fixation on tools that takes away from the looking at people and process. And so sometimes when I talk to data science leaders about, well, hey, what are the initiatives and what are you trying to solve for? It kind of comes down to things like, well, we're trying to get Jupyter Hub in, or, we want to start using TensorFlow for machine learning. And of course, it's really exciting and it's cool to be using all these new things. It's one of the fun things about data science is it's rapidly evolving and there's different approaches, and it's really, the exploratory phase and R&D is really interesting for that. At the same time, tools don't solve the bigger picture that I'm talking about. In terms of process, one of the things to keep in mind is that you don't want to do moonshots. You want to think about laps around the track. Oftentimes, data science projects, people get very high expectations. Oh, this is going to, reduce customer churn by X, right? Or our new recommendation engine is going to have this huge impact. And people get so excited about the big bang impact that they spend too long building it. And the problem is maybe they build it, but then, as I said before, if it's not consumable or the downstream dependencies aren't adequately managed and the thing can't go into production, then they spent a lot of time on something that's not going to actually deliver that impact. So think about instead, how do you get something into production, then iterate it and tune it and tweak it? And how do you get laps around the track, making it better each time, as opposed to saying, hey, we're going to have a big bang project? And the reason that's important is because if you're doing a big bang project, you can end up being very disconnected from the business. So data scientists shouldn't be expected to understand all of the practical business constraints, right? Back to my sales example, data scientists may or may not understand sort of the complexity of enterprise software sales, and you wouldn't necessarily expect them to. And if they're too disconnected, then they may not be able to build a model that is really impactful, or even if they do, they might not be able to drive the adoption of that model. So if they're too disconnected and they're not well integrated, that becomes a real problem. Another challenge that we see that leads to bad outcomes is that the teams are missing sort of key personnel muscles. There's this idea of the full stack data scientist, and I will say just full stop, that is a myth. There is no such thing. An analogy I like to use for this is like web development, right? So in 1995, when the internet was sort of new and the World Wide Web was new and people were building websites, you could have a webmaster, and that was like the one person that basically knew HTML, and they would be able to build out the website. But as the internet matured, that role started to fragment into many different roles, right? So you have the designer, you have the product manager, you have the people that are doing the Marketo and Salesforce integration. It becomes a team effort. And at this point, if some organizations say, oh, we're going to hire a webmaster, you wouldn't even know what they were talking about. But at the same time, they say, well, we're going to hire a data scientist, and they'll be able to do everything from, understand the business problems, to build the models and manage the infrastructure, to, work with DevOps to deploy the process. It just doesn't make sense. Another challenge is the idea of artisanal thinking versus modular system thinking. And we would say that you really want to think about these things like modular, right? Like Legos that snap together. But sometimes when people start up a project, they're so focused on that one little project, they don't think about the broader implications. They don't think about how they can reuse artifacts that they're building along the way. They don't think about the value of compounding knowledge by centralizing it and making it available to other people on the team. They may not even be planning for future iterations, right? So it may sort of be really a thing where they build it, they deliver it, and then they move on to the next project. But if this thing hasn't been documented, if it's not reproducible, it becomes very hard to build on it. And sometimes I've talked to organizations where they say, hey, we built a model, it went into production, but then 6 months later, we really didn't have a really good idea of what it was doing, how it was built, or how we could improve it. It becomes a very uncomfortable situation. That relates to bad incentive structures. I heard a data scientist one time say, half jokingly, I get paid for what I built this year, not for maintaining what I built last year. That's a really scary thing to think about because there's model drift, and There's ways to improve models and make them better over time if people are focused on that. Instead, what happens is that key responsibilities oftentimes fall between the gaps. Data scientists are responsible for building the model. They throw it all to DevOps. DevOps is responsible for putting it in production. They don't understand how it was built. There's a lot of information that gets lost in those transitions, and it creates risk, but it also limits the ability for the organization to understand the impact of that model and build on it and improve it over time. So what do we do about that? What are some of the recommendations that we would think of? So best practices take many different forms, right? There's people, there's process, there's technology, and all of those matter. I'm not going to talk a lot about technology because Domino's is a technology company. I don't want you to think that we're just trying to like sell you a product, but let's talk about people, right? So as I said, the full stack data scientist is a myth, it's a unicorn, they don't exist. And instead, think about different roles, right? So there is the data scientist, but there's other roles that really matter as well. The infrastructure engineers, there's a couple roles here that I think are really interesting to think about. One of them is the data science product manager, right? So if you think about building a product in an organization, the product manager has the job of understanding the needs, working with the plan to make sure it gets built and delivered through all those different handoffs from ideation to experimentation to validation to DevOps to production. And they also have the responsibility for tracking the value of that. So this might be a person who's not a data scientist, they might be an MBA or something, right? But it's more of a business focus that says, how do we understand the business problem we're trying to solve and how do we articulate that and manage that process over time? The other role that I think is really interesting is the data storyteller. And to use that website analogy I used before, right? I mean, now one of the most important roles on a web design project is the graphic designer, because they make everything sort of feel smoother and more understandable. And if your organization is relying on dashboards or other kinds of reporting, and you're expecting that the data scientist is going to be really good at like knowing how to tell that story and present the information in a way that it can be understood, that may or may not be the case, right? So you may say, hey, we want to supplement that with somebody who's really good at explaining how this model works, explaining how it was built, and telling the stories around that. The next thing we'd recommend is managing the data science lifecycle. And so first, just understand that there is a lifecycle. And I've talked to different organizations with different ways of mapping it, but the best organizations always have some kind of map that says they understand what it looks like to go from, you know, the initial idea all the way through to managing a production model. As part of that, you want to expect iteration and you want to embrace it. You want to be excited about it. So this is not sort of waterfall. This is a much more nimble approach. The analogy I use sometimes is, you know, if you think about like, how do you tell a healthy bird it's like feathers are bright? How do you tell a healthy data science team they can iterate quickly, they get laps around the track? Part of that's because you get compounding collaboration. What we mean by that is that the more people share information, the more they work together, the more they give ideas that actually grow on each other. And so you can learn faster and you can go further if you have iterations where people are teaming up and helping each other. And as part of that, I would say you really want to make sure you have auditability and reproducibility in your process. And that's even if you're not regulated. So as I mentioned, you know, many of the companies that we work with are in regulated fields like insurance or life sciences or banking, and they need to be able to show how their models were built and how they were put into production. But even if you aren't, there's still a chance that people are going to come back and start asking you about how that model was built. And being able to explain that easily is going to save a lot of time, and it's going to also help people better understand what it is the data science team is doing for the organization. So think about data science as a system, and think of it as many components. So before I talked about the Lego blocks and them snapping together. So for each step in the process, you should have a pretty good idea about what that step should look like. You know, how do you approach it? What are the things that need to get done as part of it? It's great if you can document that part of the process so that people that are coming from the outside and being brought into it can understand what to expect. And as you think about going from a single step to a system, What's great is it makes it easier to scale if you have all of these different steps understood. And of course, it's gonna be different from project to project in terms of like what ideation is actually doing or what tools are used in R&D or what it means to deploy a model. But at least having a sort of generalized understanding of those phases helps as you scale, because you want to be able to manage many of these projects. And as long as they're managed in a way where there's components that you can understand and that people can be brought into and moved around on, then it's much easier to scale. If each one is its own kind of little artisanal project with no standards and no documented processes, then it gets really, really hard to manage that portfolio. In terms of that life cycle, generally it's going to start with ideation. The key recommendation that we make here is start with the problem, not with the data. I hear all the time people say, well, we have a lot of data in the data lake and we're going to start with some machine learning and, we have the data and let's see what we can find. Apart from sort of like, that's not the scientific method, it is data science. There's a huge problem with that, which is who cares what you find unless you can tie it to a business problem. If you start with the business problem and start with the business stakeholders and say, what can we use data science to improve the business? You're much more likely to, at the end of this whole process, have something valuable. As part of that, you want to practice and master order of magnitude math. So you don't need to know exactly how much money this is worth, this project, but you should understand like, hey, are we tackling a $500,000 problem or a $50 million problem? If we had an improvement of 1%, is that worth $1 million or is it worth $10 million? And you want to do that because it's going to help you prioritize different projects within that ideation phase. As you're doing this, you want to make sure to maintain a repository of all that work you're doing so that you don't come back every 6 months and have to kind of rethink, oh, wait, what was this problem? How much was it worth to solve? What were the things we looked at? And then the final thing there is you want to make sure that you have a stakeholder-driven backlog. And what I mean by that is that if you're delivering value to the business, then you want business people coming to you and saying, hey, here's other problems we can solve. And you want them to be involved in that because then you're going to have an easier time actually deploying the results and also getting the resources that you need. If the business stakeholders are engaged with the ideation phase of your data science program, you're much more likely to actually deliver results at the end of the day. At the end of ideation, think about artifact selection as one of the key things. And what I mean by that is really, what is the end product of your data science program going to look like? I'll tell you a great story here. There was a retailer that we work with, and the real estate team came to the data science team and said, hey, we want help in figuring out where to put retail locations. It seems like a classic data science problem, right? Where should we put stores for the best return? And the data science team went and thought about that and said, yeah, it's a great problem, we'll work on that. They came back with this really cool capability, which was like heat maps. And so you can imagine looking at an aerial map of New York, and they would have, the heat map of like green is like the best place to put stores. And they showed that to the real estate team and said, hey, what do you think? Is this valuable? And the real estate team said, well, no, you guys don't really understand how real estate works, right? Everyone knows that Times Square is a fantastic place to put a retail location. You don't need a heat map to tell me that. The real thing is that when we are choosing a location, we get presented options. And what we're presented is an address, a square footage, and a rent. And what we want to know is that something we should dig into? So it's not a map and looking at a map, it's actually an API with 3 inputs and 1 output. Fortunately, the team had done that whole process in rapid prototyping. They created mock-ups and they showed mock-ups. They never actually built that model until they understood the problem better. And that was a key part of their process to make sure they got the right answer at the end of the day. Other organizations use synthetic data because if collecting data is really expensive, then they want to make sure that they are going to, before they spend potentially millions of dollars collecting data, that in fact the entire pipeline and process works. For the R&D phase, think about establishing standard software configurations that people can use. You want to have a workbench so that the process doesn't start with people like going out and trying to figure out how to download the packages or the tools they need. You don't want to lock it down too much. People need flexibility, and this is a rapidly changing field, but you certainly don't want it to be that when the cold start problem of, well, hey, what version of Python, what packages, that you don't want people to worry about. You don't want to worry about compute provisioning. They should have the hardware they need. And a really interesting point here is build simple models first. You know, I was talking to somebody a while ago and they had a great thing about, you know, look, your first model in production on a project should just be a simple regression. That will be better than a human could do anyway. And if you can get that into production, then you can go back and use TensorFlow and make it better. But don't start with like the most complex thing. The validation process towards the end of R&D is really important. And the key point I would make here is that this isn't just like a code review or a sign off. You really want stakeholder sign off, and you want the stakeholders to sign off on the business case that you're presenting. So remember at the beginning, we talked about like an ideation, understand the problem you're solving and what it's worth to the business. Part of the validation step should be to say, hey, we think we can, you know, deliver this impact. We can cut churn by 5%. And you said that was worth X million dollars. Is that still true? Like, is this way that we've done this, and is this information going to help deliver that? And the reason is because if they say no, well, you're still in the R&D phase. You can come back and you can get there, or you can say, well, in that case, let's not put all the resources into delivering this, right? Let's kill it. If this is not going to deliver the value, then that's fine to know, right? But do that as part of the validation. And then the final bullet point there is also really important, which is even null results on projects, even if you go to the validation phase and you say this is not worth pursuing any further, you want to maintain a repository of that. And the reason is because, well, there's several reasons. One is that that idea will come up again and again. If it got to this stage, it's because there's something there. And so people are gonna come back later and say, hey, maybe we should look at that again. The other thing is, of course, the world changes. Maybe new data will be available down the road. Maybe regulations will change and all of a sudden it becomes more valuable. And so having a result preserved means that when the idea comes back, you can come back and say, well, why did it go wrong? What did we learn? And how can we build on that to get better for the next time? In terms of delivery, you know, that artifact selection phase was important, but now you have to come down and say, okay, we're gonna actually build the real version of that. And that might be a report or a dashboard, it might be a batch job, it might be an API. The most important thing is that you wanna make sure that you have defined what we call a promote to production workflow. And that means that the data scientist understands that from when they declare that they are done on their work through to this being in production, what needs to happen and who they're going to go to and how they're going to get that done. And this might be where that data science product manager comes to play as well, which is you can't just throw it over the wall and say, okay, we built this model, here's an API, DevOps, take it from here. You need to make sure you understand the upstream dependencies, you know, what data is this going to need, downstream dependencies, what systems are relying on this, and you want to make sure that that is tracked as part of the project. There's a huge kind of like, you know, chasm between finished data science project on someone's desktop and production model delivering value, and you want to make sure you build the bridge across that. Monitoring that production model is also critical. I mentioned before that risk of drift. So you want to make sure that, among other things, there's no drift. But the other thing is you want to build ROI testing into it, right? So you want to make sure that you're tracking the ROI this is delivering and communicating that out to the organization. As I said, there's a lot of interest in data science. There's a lot of hype in data science, and there's a lot of money being spent in data science. And so being able to describe all of that with a dollar value to your executive leadership is going to be really, really important because they're going to want to know. And the only people who are going to be able to tell them that are the data science leaders. You should really think about having monitoring plans built as part of the deployment. And the reason for that is because the people that are delivering, the DevOps people who are putting these into production, they don't really understand what the monitoring is going to be. They can understand, like, is the API responsive or is the dashboard loading, but they're not going to understand if the information that it is providing is correct. And that's something that data science needs to take ownership of to make sure that it is not doing something that is damaging to the organization. And then finally, this sounds really hard, right? Sometimes people, we talk about this stuff, think, oh man, it's like a lot, like we're just getting started, this sounds crazy. It's hard to keep all the balls up in the air, right? So what are the things that you should be thinking about just, you know, in general? So one is, it's great to measure everything, including yourself. And what we mean by that is that, you know, you want to quantify as much as you can about the data science process, right? How many, tests are being run, how many projects are underway, how many deliver value, what is that value? Next, can't say it enough, focus on reducing the time to iterate. You want to have cycle after cycle after cycle on models. And, if the project takes, 6 months or a year, and sometimes it does to deliver an iteration, that's really, really bad. You want to make sure that you're building a process where you can understand, track, and improve models on a very, very quick basis. And then finally, really do think about socializing the portfolio impact. How is data science helping the organization? And, sometimes people are kind of shy, or they feel like they don't want to brag or things like that. But remember that there is so much hype around data science right now, and there's so much people are wondering what it can do, that they want to know that answer. They want to know, what is the impact of this program that we're running? The other advantage of socializing the portfolio impact is then other stakeholders will come with ideas, and people will start saying, wow, if data science can do that, maybe it can do this. And that will help you reach out to more within the organization and deliver even more value. So in terms of quick summary, goals, pitfalls, diagnoses, and recommendations. As I said, we have a white paper that explains all of this as well. And I hope you found this useful. What we're going to do now is take some questions. And so there's the chat box, and feel free to type questions. I'll give you all a minute or two, and then we'll start talking about that. Thank you very much. Okay, the first question is, do you have any opinions on centralized data science teams versus data science teams in the departments, basically is how they phrased it. So that's a really interesting thing, and we see it in different ways, right? So sometimes organizations will have a center of excellence. This is if it's a new capability for the organization, or alternatively, if it's an organization that felt like they wanted to be faster and more nimble in data science, they might set one of those up. In other places, what you'll see is, yeah, exactly. It's like departments are hiring their own data scientists. And the advantage of having data science at the departmental level is that then the people are really connected to the business outcome. And that's an important thing to always keep in mind, is that you don't want data science on an island. You want those people really tied to the business outcomes that they're expected to deliver. At the same time, a center of excellence is really good for developing best practices, for adapting to new techniques and technologies, for sharing information, for getting that kind of compounding centralized knowledge that, that helps organizations go from good to great in data science. Something I've seen in a couple places that I think is really interesting is this idea of, and two places actually use the word guild, data science guilds, where they say, we understand that the data scientists are working in different departments, right? So the quality engineering team has a data science group, and the marketing team has a data science group, and HR has a couple data scientists. But we're all in the same guild, and we're going to start organizing ourselves and having monthly meetings or shared Slack channels or ways to collaborate and learn from each other, even though we're not in the same department. And they really prioritize that, and they make it sort of part of the job. The advantage of that, in addition to the sort of sharing of knowledge and all that, is it helps the data science function get more essentially professionalized in a way that it's going to be able to deliver the value to the business and then explain the aggregate impact. Okay, next question. Hang on. Do you have a repository of sample artifacts or templates? So that's a good question. So I'm assuming you mean, like, does Domino have that? So one of the things that Domino does is we centralize all the data science work. And so when you log in, you can actually see different things that people are working on and how they did it. You can even like fork their projects and copy them and try it yourself and things like that. Domino has some sample artifacts on our webpage actually, in terms of like Jupyter notebooks that run within Domino. Because we're open, one of the things that's really cool is like if you find notebooks elsewhere, you can even run them on Domino. And so we have people that like they'll take like Kaggle competitions like the Titanic or the Iris data sets, and they will just load those into Domino and run those there. If you're interested, I can share some of those with you. So yeah, send me an email and I'll send you some links. Somebody asked about sharing a link to the white paper. Yes, we will do so. Okay, based on your experience, what's the most optimal way to report multiple data science project statuses to stakeholders? Well, let me think about that for a second, the most optimal way. So I think one of the important things there is to have a sort of almost like a template of how you would describe the data science project, right? So one thing with the C-level stakeholders is they don't necessarily really understand a lot about data science. So if you come in and say, oh, we've made huge progress, we have gotten AUC to this, or the R squared coefficient is that, like they don't know what you're talking about. So one thing to do is to say like, for each time you review it, say, here's the goals, here's the measures, and then here's what we're doing about it. That way they know what to expect and it can be sort of a consistent thing. So that's the first thing I'd say. The other thing I would say is, within Domino, we have, of course, like project pages and overviews. And so a lot of times what happens is people will log in and they'll go to the overview on a project just to sort of understand like where it's at and what's going on with it. And so we have companies where one of the things they'll do is like one of the things a manager of a data science team is asking these people to do is to update the project overviews on a consistent basis so that it's easy for outsiders and stakeholders to just log in and say, okay, here's where it's at, here's what's in production, et cetera. Okay, other questions? Let's see, will the video of this webinar be available in the future? Yes, the video will be available and we will send out a link for that as well. Okay, well, I think we are just about out of time on this. Thank you all very much. I really appreciate people coming and staying through this. As I mentioned, would love to engage with anyone further if you want to learn more about Domino or how we help data science teams, and feel free to come to our webpage, and we have a great blog and a lot of really good resources there as well. Thank you all very much for joining, and with that, I will sign off.